Hi, we're Team Outliers, and this is our second progress video for the project. And since the last progress video, we've started collecting data, and we will continue to collect more and more data of audio and pictures of places that are like crowded or not. And for this progress video, we will show you what our subscription page, which is our front end, look like. And we've also started doing our audio model. And for the next upcoming week, we will continue to build our audio model. And then we will also build a vision model that uses the images. And we will build our email server. And last, we will integrate everything together and deploy it for the final submission. And next, Raj will show you our current front end subscription page.
Hey, hello guys. Um, and this is our subscription page code. So we build our subscription page with TypeScript, with Next.js, and the backend database support. We have given PostgreSQL. So this is a simple subscription page, as in a project. User can scan the QR code and see this page. Once they fill up the form, it will add in the respective table so that they can get the subscription service. So this is the main form. Oh, so this is the main form, which have we have like three cases, and we have uh like all the forms below. So we have getting the first name, last name, email, as well as like the places as a checklist. And we are posting those data to a PostgreSQL. Right now, I'm running it in my local machine, but for the develop and the deployment progress perspective, we will deploy it in AWS as a container service. And yeah, we have all the styling and all the pages, and this is the connection for the TypeScript to SQL, and it has the all the connections like user, host, and DB, and as well as the SQL query. Yeah, that's it. These are all the supporting files for React.js, and we have used React and other React-based components to develop this page. Right now, this page is running, so yeah, you can do it. Page. So this is our description page. Uh, yeah, you can give your name or you can give email. And once if you entered all the input, the subscribe button will enable, or else it will be not disabled. And you'll see like the subscription was successful, and thanks for subscribing to our service page. And you can see the backend, and if you see, and you can see this details. Yeah, this page is actually the startup page for our entire project. And once the user is subscribed, and we can get users uh, need or requirement to fulfill a requirement. Once it's done, we will dive into email service agent, which is an LLM model hosted on email service. So it will fetch the user's data from the subscription table whenever the users email the bot. It will query the data with user ID, and it will see like what are subscriptions user asked. This is for like the general prospect. If the user is not subscribed to any one of the service, the model will offer us a model denied to service them. Yes, that's the spot about the subscribe page, and Claire will explain about the audio model. Thank you.
Okay, so now I'm going to talk a little bit about our audio transformer model. So our goal is to build an audio transformer model that will be used in addition to our vision or video machine learning model to detect the crowd size. So for the audio transformer model, our objective is to dissect the audios and then classify it as whether as to see whether there's a crowd or not. And then first of all, what we did in the past week was to get the data from S3, which is where we store all of our data that was collected from sensors. And then we analyze the data. So for example, here's a graph showing the amplitude versus time, as well as magnitude versus frequency graph. So, and then we have multiple or hundred or more files similar to this from our S3 bucket. So using these audio files, we pre-process the data and then try to cluster the data into different categories. So, and then for each categories, we indicate whether there's we indicate the potential number of crowds from the data. And then using that, we can feed it into the transformer model and predict the amount of crowd size. And then that will be used with the vision model that we have, and that will be implemented next week in the future. So one example that for data preprocessing is that we try to reduce the noise in the backgrounds using the spectral gating noise reduction method. And then in addition to that, we use methods such as framing so that we can cut the audios into seconds of short frames. We also use in addition to that, we use windowing, which is a method that's used to minimize the spectral leakage in framing. And then this last method that we used was overlap add method that is used to prevent losing vital information from windowing. So following these steps, we were able to get a clean data for all the files. And then this is the results of the file that we have. So the power shape is the final decibels that we will use to implement into the transform model and clustering. So right now we're just trying and experimenting different methods to see like what method would do best for our transformer model. And then we did some quick clustering and classifying of the labels just to explore the data a little bit more. So this is not the final result, it's just pure experimentation. So we use GMM model to classify the audios, and then we were able to get about 10 clusters. So for the total 10 clusters, it's separated by different decibel values. And here's the distribution of the 10 clusters. And based on that, in our experiment, we're trying to see if we can dissect the audios into these 10 clusters by giving them different range. So one example here is that for all the 10 clusters, we separated by the decibel values, the min and max from each clusters to see if this would be a good method to use for the later machine learning models. So that's all the updates that we have for the audio transfer model that we're currently building. So next week we'll have more updates on this as well as on the vision model that we're going to build. And thank you. This is all the progress we have for this week.